I once reviewed a coding agent that had run 47 repair attempts overnight. The logs looked busy. Edit file, run tests, red error, edit again. The bill was not huge, but the damage was trust. The original bug was still there. 2 new warnings had appeared. The team could not tell whether the agent was close, stuck, or making things worse. The prompt was fine. The model was capable. The missing part was simpler and more painful. Nobody had told the loop what done meant, when to stop, or when to call a human. The beginner version of an AI agent loop is usually, give it a goal, let it try, inspect the result, then ask it to improve. That can work for a demo. It breaks in production because improve is not a finish line. Looks good is not a verifier. One more try is not a budget. Without a hard contract, the loop slowly changes shape. It fixes formatting while missing the requirement. It argues with flaky tests. It repeats the same bad edit under different words. Eventually someone asks why the automation ran for 20 minutes and produced a confident mess. The failure is not always bad prompting. Often, it is missing control logic. Here is the pattern for this episode. Define the stop contract before the first attempt. I use 4 lines. Success means what exact state counts as done. Maximum retry says how many repair passes are allowed before the loop must stop trying. Escalate when names the conditions that require a human, a queue, or a safer workflow. Proof required says what evidence the verifier must return. This is opinionated, but it is based on scars. A weak loop says keep improving until it looks good. A strong loop says tests pass, lint is clean, maximum 3 repairs, and every pass must include machine-readable proof. Mechanically, the loop is small. Start with a goal and a stop contract. The agent makes 1 attempt. A verifier checks the attempt against the contract. If the verifier returns past equals true, the loop stops and records evidence. If it returns past equals false, the orchestrator checks the retry count, the budget, and any escalation flags. If retry is allowed, the next attempt receives structured feedback, not vibes. That means fields like failures, evidence, suspected cause, and required next action. If retry is not allowed, the loop reports the current state and escalates. The important detail is that the agent does not decide forever. The loop controller owns the stop rules. Take a coding agent assigned to fix a small bug. The weak instruction is, fix the bug and improve the code. The strong stop contract is, success means the targeted unit tests pass, the full lint command returns 0, and no unrelated files changed. Maximum retries is 3 repair attempts. Escalate when the same test error appears twice, when the agent wants to change public behavior, or when commands cannot run. Proof required is the test output, lint output, changed file list, and a short explanation. Now the loop is clear. Attempt 1 changes code. The verifier runs commands and returns structured failures. Attempt 2 gets those failures. If attempt 3 still fails, the agent writes a report instead of pretending. This pattern does not make agents magical. It moves the risk into places you can inspect. If your verifier is wrong, the loop will confidently stop at the wrong place. If your tests are flaky, the retry logic may chase ghosts. If success is too narrow, the agent may pass checks while missing user intent. If success is too broad, the loop may never finish. Escalation can also fail if the human receives only a dump of logs. My rule is, the failure path is a product surface. A good escalation includes the goal, attempts made, evidence collected, suspected blocker, and the next decision needed. Otherwise, you just moved confusion from the agent to the operator. Stop conditions sit at the base of loop engineering. Later in this series, we will talk about verifiers, state machines, tool permissions, queues, budgets, and multi-agent orchestration. None of those topics work cleanly if the loop has no definition of done. Verification tells you whether the contract was met. State records what happened between attempts. Budgets decide how much time, money, and risk the loop may spend. Guardrails decide what the loop is not allowed to do. Escalation decides who handles the leftovers. This episode is deliberately foundational because most production failures are not cinematic. They are loops that should have stopped 10 minutes ago. Here is the 10-minute exercise. Pick one automation you already run or want to build. Not your whole platform. One loop. Write 4 lines. Success means maximum retries. Escalate when. Proof required. Make success measurable. Replace improve copy with approved by reviewer. Spell check clean and no missing fields. Replace research more with 3-cited sources and contradictions listed. Add a maximum cost, even if the cost is only time. Then decide what structured feedback your verifier must return. At minimum, past, failures, evidence, and next action. If you cannot write those fields, do not start by changing the prompt. 3 beats to keep. First, the number one agent loop failure is often not the model or the prompt. It is no precise definition of done. Second, the stop contract has 4 parts: success condition, retry limit, escalation condition, and evidence requirement. Third, the verifier should return structured feedback, not vibes, so the controller can choose stop, retry, or escalate. If you take only one habit from this episode, write the stop contract before you write the agent instruction. This is episode 1 of Loop Engineering, a daily series on this channel, moving from foundations to fleet-scale automation. Build loops that finish, verify, and stop.